Okay, complexometric titration. The process of titrating with the use of complexes is called complexometric titration. The titration between metal ion and complexing agent chelating lesion in the presence of suitable indicator is called complexometric titration or complexometry. This involves the estimation of metal ions in the solution titrametrically through the complexation. Sites are known as chelating regions. They provide extra stability to a metal complex due to chelate effect. In this titration, the indicator used is also a complexing agent, but it should form less stable complex with metal ion and impart different distinct color in complexation agent for titration of metal ions. Ethylene diamine tetraacetic acid EDTA is a very good complexing agent for titration of metal ions. It is hexadentate lesion which may coordinate with a metal ion through its 2 nitrogen and 4 carboxyl groups. Disodium salt of EDTA is widely employed in titrimetric analysis. What exactly are the complexometric titration? The definition of complexometric titration is that it is a type of volumetric analysis where the end result leads to the formation of colored complex. The end point of any titration is an unambiguous chemical that produces color in the reaction to indicate the endpoint result. The formation of colored complex plays a vital role in determining concentration in a solution with mixed metal ions. The principle of complexometric titration, the principle is to create a complex reaction, that is the metal ion and lesions are made to interact to form the complex. The metal ion behaves as a Lewis acid. The lesion acts as complexing agent. Complex is a compound that is formed by the combination of a metal ion with a molecule that is capable of donating electrons. For example, tetraamine coprate, hexaamine cobalt third, copric ammonium ion, cobalt amine ion. In the above two examples, both copper form complex with the lone pair of the electrons present in the neutral molecule ammonia. Chelate is a complex that is formed by the combination of polyvalent metal ion with a molecule which essentially contains two or more groups that can donate electrons. Disodium ethylene diamine tetraacetate EDTA reacts with the polyvalent metal ions to result in the formation of the fairly stable water-soluble complex or a chelate compound. Lesion is a molecule that affords groups for attachment to metal ions such as EDTA. Some examples of polyvalent metal ions are given below. Bivalent metal ions, trivalent metal ions. Types of complexometric titration. Direct titration. Direct titration is the easiest to understand and implement the types of complexometric titration are the standard complexometric solution is constantly mixed with the metal ion solution till the endpoint detected. Example acid-base titration are very good examples of direct titration. The indicator is an acid-base indicator. These indicators are usually colorless. These indicators are usually colorless as the titration proceeds and the pH change causing the indicator's color to change. Back titration, during the back titration to the metal solution, an excess standard ethylene diamine tetraacetic acid solution or EDTA is added, which the analyzed to find the concentration of the metal. Therefore, the role of EDTA in complexometric titration is to find the concentration of the metal. A standard solution containing a different metal ion is used to back titrate the excess. Hence, the process is called back titration. Standard solution containing a different metal ion is used to back titrate the excess. For example, determination of manganese EDTA cannot be used to directly detect the presence of manganese. An acidic solution of manganese is prepared using its salt. An EDTA is known as volume is taken and added access to the solution. Then the ammonia vapor is mixed to maintain the pH level at 10. After this is achieved, the solution is back titrated with a standard zinc of solution of zinc. Replacement titration in this method, the metal which is to be analyzed is made to displace the central ion in a complex. The drawback of direct and back titration is that they do not provide an accurate endpoint to the titration, making the detection very hard. A better method to determining the metal in a titration is by calculating the amount of manganese or zinc that a certain metal displays from a less stable EDTA complex. For example, magnesium is displaced by manganese from the magnesium EDTA solution. This free manganese metal undergoes direct titration among with the standard EDTA solution. This method requires the addition of the excess quantity of manganese EDTA to the manganese solution. By the method of calcium, plumbum, lead, and hydrogen can also be determined by using EDTA. Indirect titration. Indirect titration is also called alkalimetric titration. It is used mainly to detect the ions such as the anions that do not react with EDTA. The protons present in the disodium EDTA get displaced by the heavy metals and then undergo titration with sodium alkali. Application of complexometric titration. This method is used to determine the various complexes of calcium and magnesium in water that act as hardening agent of water. It is a very vastly used process in the pharma industry to determine the various concentration of metals inside the medicine or drugs. In the field of biological analysis, it is used for urine sampling, blood sampling, etc. Okay, it's all about complexometric titration. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you.